Hey guys, welcome back. We are going to actually spend a few minutes going over some review about our inequalities, what they are, what they look like, how to graph them on a number line, how to solve them, and all of those kinds of things. So a lot of this is going to be review. So buckle in. Here we go. We're going to do some math and we're going to be excited about it. All right. So we know that we need to use an open dot or an open circle when we are using less than or greater than symbols. So if you're still a student that gets those confused, just remember less than looks like a tilted L. Okay. We're going to use a closed circle or dot if those symbols have an equal to sign underneath them. So less than or equal to and greater than or equal to. So an open dot or an open circle looks like that, and a closed one looks like that. That is the difference, okay? The closed one is when we have our equal to bars underneath our inequalities, okay? So that's the first thing to know. The second thing to know is that when we solve inequalities, we follow the same rules as when we solve equations. The only difference is that equations have an equal sign, and inequalities have these less than or equal to, greater than or equal to. So it's just a difference in the signs, but we use all of the same rules when we solve them. So we're undoing the operations. So if something is being added, to undo it, we subtract it. If something's being divided, to undo it, we multiply it. And so all of the things that we've learned about how to solve equations since Algebra 1 are still true. We just have to remember one rule, and that rule is this guy. We have to flip the inequality sign if we multiply or divide, either one, by a negative number. Okay? So that's the only thing that we have to remember to do. Now, I do want to go ahead and talk about how inequalities look, because we're used to them being written like this, where x is on the left-hand side. But sometimes they're written with x on the right-hand side. And what you have to know is that x is greater than or equal to 8 is the exact same thing as if we put the 8 on the left and the x on the right. We just have to keep that symbol pointing toward the 8. So if it points toward the 8, the symbol is flipped. And that has nothing to do with multiplying or dividing by a negative. That's just what happens if you have a number on the left-hand side instead of the right. So these two guys mean exactly the same thing, okay? But we like for x to be on the left because that helps us when we go to put our graph on a number line. Because it's easy to look at that and say, I know what numbers for x are bigger than or equal to 8. When I think about it this way, 8 is less than or equal to all the numbers for x. In our brains, for some reason, at least in my brain, that's a little bit harder to understand, and I have to think a little bit longer about it, even though they're the exact same thing and they produce the exact same graph. Okay, so if we were to graph that over here, a lot of times we like to put 0 in the middle of a number line. We know all of our positive numbers go this direction and all of our negative numbers go this direction. Okay, so we could put the 8 right here. And if I wanted to graph all the numbers that are bigger than or equal to 8, I put a closed dot or a closed circle on my 8 because 8 gets counted, it gets included. And we shade it the direction that our inequality is pointing. So all the numbers that are bigger than 8, that's what my number line graph would look like. Okay? So this piece of information that I wrote up here, the reason that's important is because sometimes if they give it to you like this and you have to graph it, you might want to turn it around and put the x on the left side, because we like to shade the direction our inequalities are pointing, because that makes sense to us in our brains. Okay? So we haven't really solved anything yet. That's what we're going to do down here, okay? So we're going to treat that inequality sign just like it were an equal sign, okay? So that's what we're thinking about. A lot of times, some of your teachers might have put a line through it to separate the sides of your equation or your inequality, and you can continue to do that as well, okay? Because we are wanting to graph it, I want all of my variables on the left-hand side. So I'm going to subtract that 7v to the other side. And that gives me negative 2v plus 1 is greater than negative 17 because that adds to 0. And I'm still trying to get my variable by itself, so I'm going to subtract that 1 over. And I get negative 2v is greater than negative 18. And so the last step is getting rid of that negative 2 that's multiplied by my v. So we undo multiplication by division, and guess what? I'm dividing by a negative. So I have to remember my rule up here. If I divide or multiply by a negative, I have to flip my inequality sign. So instead of greater than, we're going to flip it to less than. And negative 18 divided by negative 2 is a positive 9. So if I put 0 in the middle, that means 9 is way up here. It's an open circle because I don't have an equal to. And we're going to shade to the left because all of these numbers are less than or smaller than 9. Okay, so I want you to go ahead and pause the video and try to solve this third one on your own. And when you've solved it, try to graph it. And if you get as far as you can, but you're not sure what to do next, that's when you can push play and watch me work it out. So give it a whirl. When we see parentheses, we know we want to distribute. Okay, distributing is multiplying. So 3 times 8 gives me 24x. And 3 times negative 9 gives me negative 27. And that is greater than, if I distribute here, I get a 24x. And 4 times 1 is 4. And now it looks just like the problem we solved last time. So we want to get our x's on the same side. So if I subtract this 24x here and here, all of my x's disappeared. Now, if you got that far and you hit play because you thought you did something wrong, the good news is you did it right. But what do I do, Miss Thomas? Like, what are my answers? So let's write down what's left. Okay, so we have this negative 27 is greater than 4. We just need to decide if that's true or false. So if I put 0 over here and 4 right here, negative 27 would have to be way over here, right? So anything that's bigger than 4 would have to live right here. So is negative 27 bigger than 4? No, that is false. So the answer to this problem is actually no solutions. So when you're solving these, you just write down what's left if your letters disappear and ask yourself if what you're left with is true or false. And if it's false, there's no solutions. If it's true, that means there's infinitely many solutions. So every number is an answer, okay? So go ahead and push pause again on your video and try to work out this next one and see what you come up with, and then hit play. All right, so right here I see some parentheses, and so I need to look. I always like to write a 1 with my negative sign because it helps remind me, oh yeah, I have to distribute that negative sign. Okay, so if we do that, we've got 11x minus 4, nothing happens there. Less than or equal to 6x, still nothing happening. And now we distribute. So negative 1 times 3 is negative 3, and negative 1 times negative 5x is positive 5x, okay? So let's add these terms together. 6x and 5x gives me 11x. I still have a minus 3 right there. Nothing else has changed, so I'm going to just write down everything else. And now I want to get things on the same side of the equal sign. So if I subtract my 11x, oh my goodness, the same exact thing happened again. Hopefully it didn't freak you out this time. if we write down what's left, we're trying to figure out, is -4 less than or equal to -3? So let's put them on the number line, okay? So let's see, 1, 2, 3, 4. Let's make this guy 0 so that everybody can have a mark. So -1, -2, -3, and -4. So anything that's less than -4 is gonna, I shouldn't say it that way. So hang on a second. Okay, so what we're asking ourselves right now is -4 less than or smaller than -3? So -3 is right here, and everything that's smaller than -3 is going to be over here, because the further left we go, the smaller our numbers get. So this is actually true. And so this one would have infinite solutions. Okay, so that's what those look like when we're just graphing them. So now let's talk about other kinds of inequality equations that we could see. Okay, so we have two types. We have inequalities that use the word or, and we have inequalities that use the word and. Okay, so when we have inequalities that have the word or, that means you're going to see two different pieces graphed on your number line. Okay, and that means we can have answers in this space, or we can have answers in this space. Okay, and we write that down. We would say for this guy over here, okay, he has a closed circle at -4. So that means x is all the numbers less than or equal to -4, because our shading's going smaller. Okay, and then we can write or. And for our other piece, it's an open circle, so it would just be x is greater than, and it looks like it's at a +1. So that's how we would write those. So when we solve them, they're still going to be written with that word or in the middle. But you just need to know you're going to have two separate pieces on your number line. So if you don't have that, if they overlap somehow, then you know you made a mistake. Okay? So when we solve these, we will solve them exactly like if it said equals 10. So we're subtracting that 4 from both sides. We get 3x is less than or equal to 6. And when we divide both sides by 3, we get x is less than or equal to 2. So that's going to be a closed circle at +2, and it's going to shade to the left like that. Okay, solving the next one's a lot faster because all we're doing is dividing by 5. So x is bigger than 9. So that's going to be an open circle at 9, and it's going to shade that direction. Okay, so that's what those look like. The and type is actually, when you graph it, it's two separate pieces, but they overlap. And that's where the word and comes in. Okay, the part where they overlap is what the answer is. So this guy actually initially was from the open circle all the way to the left. And then let me get a different color, a closed circle here all the way to the right. Okay. And so we can write them as two separate inequalities. So we could say x is less than 5 because it's an open circle right there and it's going to the left. And then we would use our word and. And then for the green one, it would be x is greater than or equal to -2 because it's a closed circle and it's going to the right. Okay, so you can write them like that, or you can actually condense them. Okay, so I can take my two separate ones like this, and I can write them as one single inequality. And the way I would do that is I'm going to start right here. Let's see. Let me pick a different color. I'm going to start right here at that -2. And that circle's closed. So I'm going to say less than or equal to x. And then I'm going to go all the way over here is less than 5. And this part of the compound inequality is what I was telling you guys about up here at the very top, when we can write these either direction and they mean the same thing. So if I come down here and I look at this when x is bigger than or greater than or equal to -2, if I moved the -2 and the x around and I changed the direction of that inequality, it actually is the same as this piece right here. Okay, so x is every number that exists between -2 and +5. So we've got two examples. So I'm going to go ahead and say pause the video and work out this first one because it looks exactly like the first one that we did together earlier, except the word is and this time. So pause the video, work it out, and graph it, and then hit play to see if you did it right. So on this first one, to solve, we would subtract 3, and we would get 2x is bigger than -12. And when we divide both sides by 2, we get x is bigger than -6. So I'm going to come here with an open circle and go all the way to the right. Takes me a while to get that done on my tablet. And then over here, I'm going to add 2 to both sides. So we get 8x is less than 32. And if we divide both sides by 8, we get x is less than 4. So I'm going to pick a different color. I'm going to go to my 4, and I'm going to put a circle on it, and then I'm going to draw a line all the way here. And so my answer is this piece right here where they're both overlapping from -6 to +4. Okay, you can also see compound inequalities written like this. And my encouragement to you is to split it into two problems, okay? So we've got this side right here, okay? And if we want our x to be on the left to help us know how to graph it, then we're going to move this guy over, which means we have to flip this sign right here. And that's what that one would look like, okay? And then the other one would look like this piece, which already has x on the left, and so we don't have to do anything. We can just kind of leave it like that. Now, you can solve these simultaneously, and there's nothing wrong with that, but sometimes students get confused, and that's why I split them up differently. Okay, so I've got this equation and this one. I said equation, I meant inequality. Okay, so as we start to solve this, the opposite of dividing by -2 is multiplying by -2. And because I multiplied by a negative, I've got to switch my sign. So I've got 12 minus x now is less than or equal to +10. And now I'm going to subtract that 12 over, and I get -x is less than or equal to -2. And now I'm going to divide by that -1. So it flips my sign again. And I get x is greater than or equal to +2. That was a lot of flipping. So we got to be really careful. So that would mean a closed circle goes on +2, and we shade this direction. Okay. So I'm going to change my color when I solve this one. So same thing over here, multiplying by a -2. Means I got to flip my sign. So 12 minus x is greater than +4. And then I'm going to subtract my 12. And that gives me -x is greater than -8. And then I'm going to divide by -1. So my sign flips again. And I get x is less than 8. So another open circle right here. And we're going this way. So where they overlap is right here, a closed circle at 2 to an open circle at 8. Now, if you're graphing an and equation and they don't overlap, then you would have a no solution. Okay, so we've got to keep straight what or means and what and means. So or means you have to have two separate pieces. If there's any overlap, you made a mistake. And means there has to be overlap. So if there's not, you either made a mistake or your answer is no solution. All right? There you go, guys.